Hello, my name is Mallica Cary, and I am studying biology at Bellevue College. My project studied probiotic bacteria in both healthy and IBS gut conditions. According to the American College of Gastroenterology, 10 to 15% of Americans are diagnosed with irritable bowel syndrome, or IBS. This disease affects women almost twice as frequently as men. Symptoms of IBS can include stomach discomfort, stool changes, and bloating. Studies show excess bacteria fermentation can lead to IBS symptoms and a decrease in colonic pH levels. Clinical trials show probiotic bacteria as a potential treatment for IBS. However, the molecular mechanisms of probiotics and their effect on gut health is not completely understood. The purpose of this study is to evaluate the secreted protein profile of probiotic bacteria in both healthy gut and varying pH conditions. To observe how secreted probiotic proteins change in response to different simulated gut conditions, samples of the bacteria were isolated from the blueberry-flavored Forager probiotic cashew milk yogurt. These samples were grown in aliquots representing different pH-simulated anaerobic gut conditions for 12 to 16 hours at 37 degrees Celsius. To enrich the secreted proteins, I clarified the different samples using centrifugation and filtration. The secreted proteins were then prepared for tryptic digestion. Tryptic peptides were analyzed using liquid chromatography and mass spectrometry. The peptides were identified using the seaQuest search engine with a reference database. The seaQuest search engine revealed varying levels of secreted proteins under each pH condition. The secreted elongation factor 2 protein, or EF2 for short, was selected for analysis as a biomarker of beneficial probiotic activity. EF2 increases the probiotic's ability to adhere to the host GI tract and exhibit anti-inflammatory properties. The ratio of EF2 proteins and metabolic proteins were compared under the different simulated gut conditions. The metabolic proteins represent an internal control within the probiotics under each condition. I found probiotic bacteria released a greater amount of adhesive EF2 proteins at a pH of 6.2 compared to other pH conditions. This finding suggests that probiotic bacteria cannot resist drastic fluctuations in gut pH. This study was limited in the ability to simulate a human gut condition and the collection of all secreted proteins. Understanding the mechanisms by which probiotic bacteria modulate gut conditions can lead to further understanding of probiotics as a potential IBS treatment. Future studies can identify the specific pH range for which probiotics are most effective. Additionally, studies can confirm EF2 is an adequate biomarker for secreted probiotic proteins. These are the references mentioned in the presentation. And I would like to thank Grady Blacken from Bellevue College Chemistry Department for mentoring me on this project and for all of his help. You can reach me at the email listed here with any questions. Thank you.